All right, we are back with another exciting video here on how to utilize thermocouples in Simulink. Today I'm going to be utilizing type K thermocouples with the module Max6675. This has a temperature range between 0 and 1024 degrees centigrade. It's quite a vast temperature range, and there may be some initial calibration also required prior to utilizing these thermocouples, just so that everyone's aware. Don't want anyone to be caught off guard. I'm not going to be encompassing the um, calibration element within this video. I am simply going to be teaching you how to create the S function builder block in order to get the raw data in. Okay. Please note I have wired this correctly, so sit back and enjoy. All right. So how do we set this up? Okay, that's a great question. This is how we set up. We got some wires here. They have some colors. Got your two thermocouples. Got your Max6675 stuff. You got some orange jumpers here. Got your Uno. Okay, got the working code in the background. You have your pin setup. Okay, so the jumper stuff, the orange jumper stuff, that's this. Okay, so you're jumpering, the GND, the VCC, the SO, the SCK between the modules, and then the Arduino is being connected in the corresponding locations as you see. These are the wire colors: brown, red, orange, green. Those are the wire colors that are doing the connections. You can understand the rest of this. Okay, here's some fritzing images. They were nice. I thought I put them in there. I like the Arduino images more, to be honest with you, so I took some more pictures and I put them in this little document. Okay, so here's some images of the orange jumpers. So SCK, SO, VCC, GND, those are being jumpered together. And then you have your wire colors, your brown, your red, your orange, your yellow, your green, your blue, like you saw in the pinouts above. That's where the color schematic is coming in. Okay, so here's some other pictures in case you're interested. I thought everybody would like seeing these because I know I'm a visual person, so I know other people are too. And then we had to do this step-by-step thing. Basically, I said, here's my Arduino stuff. Okay, now let's put it in a text file. Let's show the one-to-one relationships. Okay, so here's a bunch of one-to-one relationships as to how the text file that I'm creating before I dump all this stuff into the S function builder block shows up. There's an include section, there's an output section, and then there's an update section. Okay. The update section is a discrete section because it only happens once or under very unique conditions. Okay. So uh, that's why we have to declare a discrete state of 1 when we're building the S function builder block later. Okay, so we're going to move on here. Here's your input code, here's your output code, here's your discrete code. All right, so now we have to define the baud rate, okay, because the S function builder block doesn't let us define the baud rate in the S function block itself. So we have to actually define the baud rate in the hardware settings. So you go to hardware, go to hardware settings, hardware implementation, Arduino Uno. Under the Arduino, you have to change the hardware board from nothing to Arduino Uno. Arduino Uno, and then you go down to hardware board settings. You drop down target hardware resources. You select serial port properties. Change the baud rate from 9600 to 100, 15,200. Okay, and that's how the baud rate is defined. Okay, in Simulink, you click OK. Okay, and now you define the the time step or the delay. And this is in thousandths of a second. Okay, so we have 250 divided by 1,000. What does that give us? It gives us 0.25. Okay, so 250 divided by 1,000 goes 0.25. Okay, so here's the 0.25 seconds. Okay, so again, you click hardware, hardware settings, solver, go down to fixed step. Change the type to fixed step if it's not fixed step already. Change the solver from auto to discrete. Drop down the solver details and change this from auto to 0.25. Then click OK. Okay, now we're going to go over here. We're going to build the S function builder block, and then we're going to open that, and we're going to name it. We're going to define a single time discrete time state, or a number of discrete states. We're going to change that from a 0 to a 1. Then we're going to go down here. We're going to add the outputs. And then we're going to begin copying and pasting stuff over from that text file that we created. Okay. So section 1 is the include or the input section. Then we have the output begin section. Then we have the update section. So I'm literally just copying and pasting this stuff straight from the text file into the S function builder block. And this is what makes things a lot easier. All right, now we have to generate the TLC wrapper. Okay, and so this is how we do it. We click the build button over here. We check this box if it's not checked already that says generate a wrapper for TLC. Then we click build. Then we verify that this build log is doing something, and then it says successful. And after it says successful, you should see all of this stuff show up over here in your project window. Okay, so now up here, step 9, okay, update wrapper code. Okay, so basically what I'm trying to say here is open up the file that says underscore wrapper.c and then find the word void. In front of the word void, write extern C. This will allow you to call these things as external C functions. This is important because if you don't do this, nothing will work. Likewise, the next step is equally as important. You have to change the extension from .c to .cpp. You have to do this, otherwise the code will not work. Okay, now finally you go to hardware, change the stop time from 10 seconds to INF, and you click this monitor and tune button. This is very important. This you have to do it this way for the Arduino Mega and the Arduino Uno. The Arduino Nano, on the other hand, you just click simulation and play. Why? I don't know. It just that's the way these things work. Okay, obviously you've already seen the program running, so what I'm showing you here now probably makes sense by this point. Okay, thermocouple 1 equals temp 1, thermocouple 2 equals temp 2. Okay, so here's the data that changes over time. Great. We're so happy. Okay, now that we got all of that out of the way, and it's like 7 minutes in, let's actually build this now because I'm pretty sure that everybody's really wanting this to be built by this point. Okay, so we're gonna click stop. Okay. Uh, we're going to exit out of this. Exit out of this. Okay. Folder. Okay, so we're going to go back to the original program here. We're going to get that S function builder block code of text. This thing that I said was a straight copy and paste. And I'm just going to use this. All right. And if anybody has any questions on it, they can review it or they can ask me. Okay, so finally here at the end of the day, what I need is I need the libraries. I need the libraries for this Max6675 thing. Okay, so what we do is we go into the Arduino libraries, Max6675 library master. Here's the libraries. Okay, I just pasted them right there. Great. Beautiful. Okay. I want to click Simulink, create model. Okay. I'm going to take this. I'm going to take these instructions. I'm going to put them over here. And I'm literally going to follow the instructions I gave you. Because I like to be consistent with the instructions I give people. It makes people less confused. Okay. So the first thing I'm going to do is I'm going to save this. And I'm going to save this as Max 6675 S. Okay. So now I have this over here. So now what I need to do is I need to go to apps, Simulink coder. Okay, so now that I got that figured out there, I have to click settings. And I have to click hardware implementation. And I have to select the Arduino Uno. Okay, so after you select the hardware, the Arduino Uno, uh, you can click target resources, change this, click OK. That's when the hardware button comes up because now we've defined a board, hardware settings. Okay, now we're going to go back to solver, fixed step, change this to discrete, click down here, 0.025. Okay, click OK. All right, now what we're going to do is this function builder. Okay, we're going to call this Max6675 probe. Number of discrete states 1. Okay, it's inherited. Okay, so now what we're going to do is we're just going to click up here. Okay. Output. Update. Okay. Click back into this. Temp 1F. Okay. Generate wrap. Okay, now click build. All this stuff pops up over here. Okay. Save that. Okay. Here's the wrapper. Look for the word void. Oops, extern. Need the N. Okay, it's blue. Good. All right. Change it from C to CPP. Throw some displays in there. Okay. Now, change this. F. Click save. Click monitor and tune. And there you go. Beautiful, isn't it? Works wonderfully. Okay, so now a more advanced question is, okay, Nate, now that this works, is there any way to like call these, libraries from outside? Well, that's a really good question. Okay, so now that we know that this works when the libraries are included, okay, we're going to stop this. Okay, I'm going to remove these things. Okay, we're going to go to the libraries tab right down here. Okay. Okay, so now we're going to say add path, inc path. And you remember this is the path to that library. Okay. There you go. Build, overwrite. Okay, so it says successfully done something. Okay, great. Save it. Okay, here's the old wrapper. Gotta delete that. Gotta update the new wrapper. Whoopsies. Okay. There you go. Mm. Yeah. There you go. Yeah, I think that's pretty cool. So now I can, well, I could like do some more fancy stuff in there, call more libraries and whatnot. But I mean, at the end of the day, all you're doing is manage libraries. Okay, installed. Yeah, right there, that one. Okay. So you just go into your Arduino libraries, you open up this Max6675 library, and bam, just copy or you just reference that library location, which is right here. So in case this doesn't work, I will include the library in and of itself in my tutorial file. Okay, I think that this is pretty straightforward. So at the end of the day, uh, step one is run it in Arduino. Okay, that's step one. Step two, build this S function thing. Okay, this template. Step three, go over here to um, the MATLAB and create a model. Okay, define the hardware, define the baud, define the delay, create the S function builder, and then copy and paste this stuff into the S function. Generate the wrapper and the data and all that stuff, which is right here. Okay, and then update the wrapper. Okay, and if any questions arise, please reach out to me. All right, I hope that was a very informative tutorial, and I hope that everybody liked it.